Let's learn regression analysis using Excel. Regression analysis is a set of statistical methods used for estimation of relationship between a dependent and the independent variables. We can use it to access the strength of the relationship between variables and for modeling the future relationship between them. How to apply the regression analysis? In Excel, we use regression analysis to estimate the relationship between two or more variables. We can use regression tool through Analysis ToolPak. There are two basic terms that we need to be familiar with. The dependent variable is the factor that we're trying to predict, and the independent variable is the factor that might be influencing the dependent variable. Let's go to our Excel file to understand this better. We have table here with two independent variable and one dependent variable. The independent variable here is the distance in kilometers and the transport mode, and the dependent variable is something which is dependent on these two independent variables. We see here for 350 kilometer distance by train, it's 3 hours of the travel time. These numbers are not the actual verified numbers, these are just the random numbers. But here what we have to understand is for travel time, both the distance and the transport mode is required for this travel time to be 3 or 2 or whatever the number of hours. So here there are two independent variables where distance and the transport mode is not dependent on each other, but the travel time is dependent on these two independent variables. Let me hide this transport variable for now. And using one independent and one dependent variable, let's do the regression analysis. As we just discussed, regression analysis is to understand the relationship between the two variables and how closely they are dependent on each other so that we can prepare the future models. Regression analysis is mainly used to prepare the future model based on the dependencies or the correlationships. Let's do the regression analysis in the traditional method. For that, select the variables, go to insert and select the scatter chart. We see these are the plots which are scattered all around. X-axis has the distance in kilometers, and these are the plots for time taken to travel in hours. Looking at the scattered plots, we don't understand the relationship between the total distance and the time needed to travel. Let's use the trend line to understand if there is any correlation between the kilometers and the time travel hours. To apply the trend lines, go to trend lines from the add chart element, and let's go to more trend line options. We have multiple trend line options here. Polynomial is again not covering all the variables. Moving average, again it's not covering all the variables here. Let me give order 6 for polynomial. Here when you see the curves are too high, we don't have any data here for 250, but we see the curves have gone high and it's gone low. So I don't think this is the actual trend line that we have to consider. This is again not the best fit. For this example, we actually don't have any perfect best fit trend line. It means that this is not the right data for us to understand the correlationship. Let me select the linear trend line. Let me format the trend line. For that, I have to change the color, and let me keep it as green with the width of 2. and I don't need this dotted line, so let me make it as one straight line. After selecting the best fit trend line options, we see that we have an option for display equation on chart and display R-square value on chart. Let's keep this aside, and we now see that the relationship is 0.046. The R-square value will help us understand how is the relationship between y and x-axis. If the R-square is 0, it means there's no correlationship between independent and the dependent variables. If the R-square is 1 or nearing to 1, it means that there is a strong correlationship between independent and dependent variables. In that case, using this formula, we can understand what is that slight difference in that correlationship, using which we can plot the model for the future. Here in our case, this R-square value is almost nearing to 0, which means that there is no good correlationship between the independent and the dependent variables, and this is not good for any further analysis, and we cannot forecast any future values based on the correlationship that we have for now. This is a traditional way of doing the regression analysis. Excel provides a data analysis tool pack which can provide a better regression analysis on such data, and we can get a little more clear insight about the correlationship between the independent and the dependent variables. Let's use data analysis tool pack and understand the R-square values and the correlationship values. Let me delete this chart. I have my data analysis tool pack here. For those who does not have the data analysis tool pack, let me show you how to add this. Go to File, go to Options, Add-ins, and here select Analysis tool pack and go. We see that Analysis tool pack is already ticked for me. If it's not enabled, you have to enable it and click OK. Let me go to Data Analysis tool. We see regression here from the list. Okay. We see input Y range and input X range, independent and the dependent variables. Input Y range has to be the range on which we are going to do the prediction for the future data model. Let me select time travel hours, and x-axis is that independent variable. As I've selected the headers as well, I'll have to check labels to tell this that the first row is the label and it has to be excluded. My output range, I can select it from the same sheet, and let me not click on anything here, and just let's click OK here. Now I got the summary output where I have regression statistics, ANOVA, which means analysis on variance, and this shows the slope for the distance. Intercept is the slope for the distance in kilometers. First, let's understand the regression statistics. For that, let me just reduce the decimal values to 3, and here let me do the same thing for this, 3, and again the same here. In the scatter plot, we saw that R square was somewhere as 0.04, and here we see almost the same value for R square. This shows that there is very minimum correlationship or almost no correlationship between the independent and the dependent variables. Standard error is almost nearing to 1, 0.97 is almost nearing to 1, and all these ranges from 0 as the minimum value and 1 as the maximum value, and it can also go to the negative values. And this one is almost nearing to 1, which is the highest. It means that the data has high level errors in it, and the dependency is very low. It's almost 0 or null, and the reason is because there are too many errors. These are just a simple understanding about the regression statistics. Analysis on variance is not applicable here, as our data is not a good data to have this analysis. When the independent variables and dependent variables are not correlated, we won't be able to predict any data model for the future based on the existing relationship. This way, regression statistics helps us understand the type of data that we have, the level of correlationship, and based on the good number of correlationship percentage, we can understand how accurate the predictions can be for the future data model. Let's have a look on regression analysis output here. As I mentioned, multiple R value shows us the correlationship coefficient that measures the strength of the linear relationship between two variables. The larger the absolute value, the stronger the relationship. And if the R value is 0, then the relationship is low, and if it is nearing to 1, then the relationship is good. R square signifies the coefficient of determination, which shows the goodness of the fit. Adjusted R square is the modified version of R square. Now let's use a good example for our regression analysis. The previous data was not a good data. We did not get a good analysis on that particular data because the independent variables and the dependent variables were not correlated, and the correlation percentage was very less. It was almost 0. Let's take another example. This seems to be a good example, and let's see if we have a good correlation between the dependent and the independent variable in this example. We have age here and the happiness rate based on the age. Let's see how the correlation works for this. Let's use a traditional method first, and then let's understand the Analysis ToolPak output. I'm going to select these two variables here. Insert, scattered plot. We see that we don't have data from 10 to 20, and these portions are little blank. Let me double click to make the modification. Under access option, we have minimum as 0. Let me make it as 20. Now we have our dots plotted all over the chart. Let's give a different background to this chart. For that, let me go to chart design and go to this blue background. Let me remove the grid lines, and now let me plot the trend line for this. Here we see the trend line options, more options. For this example, linear trend line is the best fit, as we see that the line has been passing through almost all the scattered plots. Let me check the display equation on chart and display R squared value on chart. And here our R square value is almost nearing to 1, which shows that the correlation between the variable and the independent variable is very good. Let's do the regression analysis on the same data using our Data Analysis ToolPak. For that, go to Data Analysis tab. Select the regression analysis. Okay, and the input y variable, the dependent variable is this, and the independent variable is our age. As I'm selecting the header also, I have checked the labels here, and the output range, let me make this as my output range. I'm not going to tick on any of the plots here. We have our analysis here done, and let me change this value to 3-digit decimal. From this example, we see that the multiple R value is 0.987, As I mentioned, that if this value is nearing to 0, then it means that there is no correlation or very bad correlation between the independent and the dependent variables. And if it is nearing to 1, then it means that the correlation is very good between the independent and the dependent variable. So here in our example, 0.98 is almost nearing to 1. This shows that the strength of the relationship is very good. R square also determines the same thing, where it is called as the coefficient of determination. 0.97, which is almost nearing to 1, which shows that this is the good fit for the linear regression, and there is a very good dependency between the independent and the dependent variable. For a linear regression analysis, we don't have to look much into the analysis on variance, but we need to look at the significant F factor in analysis of variance field. We say that if the significance is less than 0.05, then the model is okay. If it is greater than 0.05, then probably we need to change another independent variable. Here the significant value is 0.00. Here the significance value is 0, which is less than 0.05, and that's the reason we can consider this as a okay model. From the last section here, we see intercept, age and their coefficients. From the scatter plot, we see that y is equal to minus 0.0764x plus 6.7286 is our equation for the trend line. And this 0.0764 is derived from the age coefficient, which is 0.0764, and this 6.7286 is the intercept coefficient here. That is what we see here. This is nothing but the equation, which is y is equal to bx plus a, where b is our age coefficient into x is our x variable plus intercept is this intercept coefficient. Let's take an example for the data that we have here. Let me take the first value, which is the age 24, which is our x coefficient. Here, as per the formula, the age coefficient is minus 0.0764 into 22 is our age, which is the first age value that we have in our table, plus 6.7286 is our intercept. When we multiply minus 0.0764 into 22, we have minus 16808 minus 1.6808 plus 6.7286 is 5.0478. As I've done it here. For our age, which is 22, our y variable is 5.0478. As per our table, it's exact 5. There is a slight variance here. Let's check the same for age 70. We don't have the age 70 in our table here. This sort of a regression analysis is used for us to even predict the data models for any other range. It means that if age is 70, what would be the happiness rate as per our regression analysis? We have the same factor here, which is 0.0764 into 70 is our age variable plus 6.786 is our intercept, and now we have the total as 1.409 as our output. It means for age 70, the happiness rate will be 1.5. This is what the analysis helps us understand the output for the variable which we don't have in our list. This helps us to predict the output for the variable using the database. Through this linear regression analysis, we can predict the data range. Using linear regression and deriving the y is equal to bx plus a formula coefficients, we are now able to derive the happiness rate for 70 based on the previous variables. Now let's move on to the highlights of this video. The aim of this chart is to see whether there is a correlationship between dependent and independent variables. Modeling linear regression in Excel is easier with Data Analysis ToolPak. It's always recommended to have a look at summary output while you're doing regression analysis using Data Analysis ToolPak in Excel.